Okay, good afternoon, friends. Let us start the next bit of reliability. So, in last lecture, we have discussed about the series system, and we have solved some examples. So, the series system in a block diagram, all the components are connected in series, and all n components should perform the function. If any single component is not performing or fail, then we can say that the complete system will not work. And one of the example, you can take the bulbs or LEDs arranged in a series, and assume that there are 100 LEDs or small bulbs, and if any one of the bulb is not working, then the complete that series, you can say it is not working. This is the generalized example of this case. So these are the some characteristics of series system. Then we have discussed about the reliability. It is nothing but the product law, based on the product law. So it is summation of product of all reliabilities. You will get the reliability of the system. Then we have solved some numericals for this. And then we have also discussed if a system is given having different reliabilities, then if we will increase the reliability of any system by 0.1, system any component 1, component 2, component 3 by 0.1, 0.1, 3 times respectively, by keeping other two constant, then it is observed that we have solved the numerical. Just for brush up I am taking. So we arrived at that whenever there is weakest component, the component is having very smaller reliability. If we will increase the reliability of that weakest component, then the system reliability will increase by highest amount. So the improvement in the reliability of system is higher when the reliability of weakest component is increased by 0.1 in comparison with the cases of other two components. What this suggests? This suggests that if anybody want to increase the reliability of the series system, then he should concentrate on the improvement of reliability of weakest component, reliability of poorest component of the system. Okay, so these are the some of the glimpses of last. Now let us start. Parallel systems. So here the name only itself indicates the parallel system. All the components are connected in parallel. So here very important criteria is all components must fail for the failure of the system. Means a system will work up to the last component working. Assume that there are 100 components. Again, similar example. If 99 fail and only one is working, then also the system is working. This is the characteristics of the parallel system. So the system will fail when all components will fail. So the applications, you can see here the applications in jet engine, braking system, then tires in truck, then projector, light tubes. Many examples we can take, no problem. Okay, so here parallel system. Advantages, we can say what are the advantages of this parallel system is concerned. So to improve the reliability of system by making some of the equipment redundant to the other. So here the reliability of the system can be improved by making some of the equipment redundant, because it is not the case that all should working at the same time. So this is the advantage. Excessive preventive maintenance can be pursued with no loss in plant availability, since separate parallel units can be isolated. So see, there are different parallel units, and if there are different 7 lines, 1, 2, 3, 4, 5, 6, 7. I am doing maintenance for preventive maintenance for line 1 any machine. Then at the same time, remaining 6 lines are working. Or assume that anyone is failure, then also 5 lines are working. As this is in parallel, so we can isolate the typical 1 or 2 line segment and machine, and this extensive preventive maintenance can be taken care as far as this parallel system is concerned. Then in the event of failure, Corrective maintenance can be arranged under less pressure from the production or from competing maintenance tasks. See, in series, if there is a maintenance, corrective maintenance or some failure is there, and immediately action is required to be taken. In such cases, in series, that system, the complete line is stopped. That one instrument stop, complete line stop. No any machine is working and completely stoppage of the system. Therefore, there is a huge pressure that the whatever the breakdown or corrective maintenance is there, immediately it should be carried out. But in case of parallel system, not that much pressure. Let it be somewhat corrective maintenance, preventive maintenance. The other parallel systems are running. So it is these are the some of the advantages of this parallel system. Now having some characteristics of this parallel system. So here the system consisting of independent parallel components. So here in the system, there are n components. If system fails to function, if all n components fail, this is very important. If there are total n components, then for failure of the system, all components should fail, all components must fail. As this is parallel system, it will work up to the last component failure. EI, component I is functioning properly. Okay, so last time Maheji, you have asked about what is this E. So this is nothing but the component I, that every component that we are considering, if there are 5, if there are 4, whatever, that I, whatever components are there, they are functioning properly. And this EP indicates the parallel system of n component is functioning properly. So EP is nothing but the parallel system, whatever system we are considering the n components. It may be 5, it may be 10, it may be 15. So parallel system of 15 component is functioning properly, then we will call it as EP. So now this reliability of this parallel system is given by probability of EP. That parallel system of n component is functioning properly, and reliability is nothing but the probability of that all n components, that parallel system is functioning. I will not say all here. The parallel system is functioning properly, so that we can say the probability, it is probability of this system of n component functioning properly, it will give us to this reliability of the system for parallel. So these are the some of the basics. Now let us see how to calculate this particular RP, reliability of parallel system. So some of the things we have discussed in last time, let us have some revision as far as these points are concerned. So here we have considered one example also. So this RP is nothing but equal to 1 minus summation of product of, okay, so this product 1 minus Ri, it may be 1, 2, 3. So last time we have seen example, this is 1, this is 2, and this is 3. Then you can say that here 1 minus in bracket 1 minus R1, 1 minus R2, 1 minus R3. If you are having R1 value 0.8, 0.7, and 0.9, so if you substitute the value, you will get the value of reliability of parallel system, you will get some value. So this is the formula for parallel system. In series system, we are just going for R1 into R2 into R3, that this is the product of summation, and here it is the sum of product, but the formula is 1 minus Ri. I may be from 1, 2, 3, 4, 5, whatever depending upon the condition, or whatever depending upon the given data. Parallel system of independent components follow the product law of unreliability. We have discussed the product law. And friends, now without wasting time, let us have 2-3 numericals as we have solved for series configuration also, and we will easily proceed further. Okay, suppose the system consists of 4 components arranged in parallel. The first 2 components have reliability 0.9, and time t is equal to 1 year, and the other two components have reliability 0.8 and t is equal to 1 year. What is the overall reliability of the system at 1 year? So you may go for drawing the diagram. If no, you may continue with the same, no issue. So here if you see similar diagram you can draw. Similar diagram you can draw. So if you want, we can go for drawing a diagram. So here I can say, I will say R1, R2, R3, R4. Anything you can give names, or you can go for drawing the diagram, whatever problem. So if your choice is yours how to proceed. So here 0.9 two components and 0.8 two components. So I will say here what is given. So you can say here 4 components are there arranged in parallel, have reliabilities R1 0.9, R2 also 0.9, two components T 1 year, and other two components reliability is 0.8, R3 0.8, R4 0.8, both for T is equal to 1 year. What is the overall reliability of the system? So if you want, you can go for like this R1, this R2, this R3, and this R4. See, choice is yours. You can go for drawing such a diagrams also while the question is asked. Okay, and accordingly you can proceed. A similar diagram we have discussed in last case also, if you see. So same diagram we can construct in this case also. So if I will add here, okay, arrange in parallel, and you can say here R1, reliability 2, component number 3, component number 4. And here then further you can say what is the formula for your reliability. So just now we have discussed reliability of parallel system is equal to what is formula. So you Madhavji, please mute. Okay. So let us proceed further. So what is the formula if you see?
Yes. Parallel connection.
Okay. So what is the formula we have discussed? We will write the formula and we will proceed further. So 1 minus this is the summation of product of 1 minus Ri. So I will directly write here the product. One minus the product of 1 minus R1, 1 minus R2, 1 minus R3, 1 minus R4. Madhavji,
Yes, yes, just a minute.
will you please mute yourself? If you want to give answer, put in chat box. No problem. Uh, okay, so I will substitute all the values. 1 minus here, 1 minus 0 0.9, 1 minus 0 0.9, then 1 minus 0 0.8, 1 minus 0 0.8. You can go for squaring also. So 1 minus whatever. So I can 1 minus 0 0.9 square, 1 minus 0 0.8 square. So finally, this RP value is interested, and you can say RP value is equal to 0.996. This is your final answer. So in this way, you have to proceed for calculation of this system reliability. If the numerical is for parallel condition. Okay, then let us move to next problem. Okay, so this is next numerical. Evaluate the reliability of the parallel system which has reliability block diagram as shown in figure. So by observing figure, you can come to know that there are 4 components, R1, R2, R3, R4. The reliabilities of the components given in figure are for a mission of 90 days. Assume that failure of any component does not affect the functioning of other. Okay, no problem. So this assumption is made. Simple friends, this is a simple, you can call it as this parallel system, and I will say this is component 1, then component 2, component 3, and component 4. Okay, and this is reliable, this parallel system. Okay, so let us proceed directly for calculation purpose. I will write down first what is given data, then I will proceed for solving the numerical. So here you can see that given R1 is equal to, so R1 value 0.6, R2 0.75, then further R3 0.95 and R4 0.8. Okay, so now in this case you can simply say this reliability of this parallel system is equal to 1 minus, in bracket, 1 minus R1, 1 minus R2, 1 minus R3, 1 minus R4. So here you can say this is 1 minus, I will say 1 minus 0.6, 1 minus 0.75, then 1 minus 0.95, and next case 1 minus 0.8. So if you further you want to proceed, you can proceed. 1 minus here 0.40 into 0.25 into 0.05 into 0.20 or 0.2. If it is 0.001, so 1 minus 0.001, you will get 0.999. Friends, this is your reliability of the system. Okay, take 1-2 minutes for completing. reliability of system. Okay. Now next, the similar problem as last type what we have taken. Now similar case, we will go for one more problem. So here a system has three components connected in parallel. From a reliability point of view, having reliabilities 0.2, 0.4, and 0.5. So here very first the three reliabilities are given as 0.4, this 0.2, 0.4, and 0.5. This is very first point. Okay. Now respectively for a mission of 400 hours, what is the percentage increase in the reliability of the system in each of the following cases? Now three cases are given. The reliability of first component is increased by 0.1 and that of second and third kept constant. Here very first we have to calculate the reliability of the present system before going for case number 1. Then we want percentage increase. Let us start case number 1. So case number 1, that first component reliability increased by 0.1, 0.2 becomes 0.3, 0.4, 0.5 constant, second and third. Reliability of second component is increased by 0.1 and that of first and third remains the same. So first component 0.2, second component 0.4, so it becomes 0.5 for this case, and third will be as it is 0.5. In the third case, reliability of third component is increased by 0.1. So first component and second component as it is 0.2, 0.4, and third component is 0.6 instead of 0.5. And then we have to calculate here, friends, what is the difference in the reliability and what percentage increase in the reliability of the system if we will go for following the changes as mentioned. Okay, so my very first task is to have this 0.2, 0.4, and 0.5. So very first calculate the reliability for these cases. Okay, so I will say here very first. Given. So R1, R2, R3 given. Reliability of first component 0.2. Reliability of second component 0.4 and reliability of third component 0.5. So now what is the formula, friend? Reliability of system is equal to 1 minus into bracket 1 minus R1, 1 minus R2, 1 minus R3. If you substitute the values, it will become 1 minus 0.2, 1 minus 0.4, and 1 minus 0.5. So if you go for calculating, friends, or again I will write 1 minus it here 0.8 into 0.6 into 0.5. So I will say 1 minus 0.240. So you will get reliability of system is equal to 0.760. You can mention here for a mission of 400 hours. This is very important, friends. So this is now the reliability of the system at the basic conditions. Now hereafter 3 different conditions are given and we have to calculate if 0.1 is increase in the component of 1, 2 or 3, increasing the reliability by 0.1 in the component of 1, 2 and 3 by keeping other two component constant. What is the percentage increase in the reliability? That, friends, we have to calculate. Okay, up to this understood, now we will proceed for a table and similar these calculations now I have gone in very detail. So I will take it direct some calculations and we will proceed for some of the next calculations. Same calculations we have to repeat, only difference is that the reliability is changed as per the given data. Okay, so friends, here I have mentioned what is given 0.2, 0.4, 0.5 and 0.760. This we have calculated. This is our basic thing. Now case number 1 we will go for. What is case number 1, friends? You can see here case number 1. What is case number 1? The reliability of first component increased by 0.1. So 0.2 becomes 0.3. This will be as it is 0.4. This will be as it is 0.5. So we have to calculate the reliability of the system. We have to calculate the reliability of the system. So how you can calculate? So here one calculation I will show you as a sample. I will say reliability is equal to 1 minus in bracket 1 minus 0.3, 1 minus 0.4, 1 minus 0.5. So proceed for calculation. 1 minus 0.3 it is 0.7. Into 0.6 into 0.5. Go for calculation. 56.3, 0.7. 732 0.21. 1 minus 0.21 you will get 0.79. 1 minus 0.21 you will get reliability of the system is equal to 0.790. Friends, this is not the right answer. What we want to calculate? We want to calculate the percentage increase. You can calculate this. Percentage increase is equal to 0.790 minus 0.760 divided by 0.760 into 100. Otherwise you will get in fraction and then you will get this percentage increase is equal to 3.95%. So friends, now similar cases you have to start. Now this is case number 1 I have gone for. Now you have to go for case number 2 and case number 3. Friends, what is case number 2? So I will say here 0.3 constant, 0.5 constant, 0.4 will become 0.5 and here first constant, second constant, third will change. So in the case number 1 we have said here 0.3. In the case number 2 we have say here we will say here 0.4 to 0.5 and in the case number 3 we will say here 0.5 to 0.6. And then friends, moving for further calculation, not that much difficult. So here you can say RP is equal to 1 minus into bracket 1 minus 0.3, 1 minus 0.4, 1 minus 0.5. So here two places 0.5. So 0.5, 0.5. This is go for calculation. Okay, something wrong here in this case. So I will not change this basic thing. So here I have to give the same value. So here I should take 0.2, and here also I should take 0.2. So now the calculation will become like this: 1 minus 0.2, 0.5, 0.5. Okay. So in this way you have to proceed 0.25 into 0.8. So it is becoming 0.2. 1 minus 0.2. I will say 1 minus 0.2. So you will get RP is equal to 0.8. So now friends, percentage increase is equal to 0.8 minus 0.760 divided by 0.760 into 100 is equal to so it is 5.26%. Okay, so now let us move to next. Now the first 0.2 we have kept it as 0.2, second 0.4 we have taken as 0.4, and third is 0.5. It is increased by 0.1 and it is becoming 0.6. So now friends, RP is equal to 1 minus 0.2, 1 minus 0.4, 1 minus 0.6. You will get here RP value as 0.808. 0.808. Now friends, calculating the percentage of increase in the reliability of the system if the reliability of component 3 is increased by 0.1, so 0.5 it becomes 0.6. So now how to calculate? 0.808 minus 0.760 divided by 0.760 into 400. Friends, calculate. So this answer will be 6.32%. So if you see, if you highlight that where you are getting this higher percentage, so this reliability is observed to be decreased highest when the rise in this highest component. Third component means highest reliability component, or the component is having highest reliability. When the rise is made in such a component, then the percentage of the increase in the percentage of the reliability system is maximum. Okay, take 2 minutes and then we will proceed further. Okay, so let us proceed further. So it is observed that 0.1 increase in the reliability is made for all the components, and the effect of this increase in reliability on the components on the percentage increase of reliability of the system is analyzed, and from the result observed, it is noted that percentage increase in the reliability of the system is maximum if the reliability of the highest component, good component, is increased rather than weakest component. Okay, or we can say best component. So it is summarized like this: the improvement in the reliability of the system in percentage is higher when the reliability of the best component is increased by 0.1. What is best? So we have discussed in numerical, and this numerical is purposefully taken with the intention that you will come to know practically. Therefore, 0.2, 0.3, and 0.2, 0.4, and 0.5. So the component which is having reliability of 0.5, we will call it as best component because it is having highest reliability. So if we increase the reliability by 0.1 of the best component as compared to the other two cases, the improvement in the reliability of the system is higher, and we have noted it from the numerical also, or problem solving also. This suggests that what this indicates, if a system engineer wants to improve the reliability of a parallel system, then he or she should concentrate on the improvement of the reliability of best component, not the weakest component. So we can make it generalized. Once again, I will repeat that in order to improve the performance, or in order to improve the reliability of parallel system, one should improve or concentrate on improving the reliability of the best component. If the reliability of best component is improved, then the performance of the system will also improve for parallel systems. Thus, in this case, the best component dictates the reliability of the parallel system. Recall the poorest component. So, if we want to compare with the series, in series we have discussed that if we want to improve the reliability of a series system, one should concentrate on the improvement of the reliability of weakest component. And in parallel system, if we want to improve the performance of a parallel system or reliability of a parallel system, one should concentrate on the reliability of best component. So in series system, weakest component; in parallel system, best components. Friends, this is about this parallel system. And then there is a combination also based on the redundancy, that combination of series parallel. So redundancy, high level, low level, and k out of n, and one or two numericals for this and one numerical for k out of n. Also we will discuss in this in the next lecture. Thank you very much.